Welcome back. In the second week, we'll start looking at the object-oriented programming principles. And we will start with the concept of objects and classes. So at the end of this lecture, you should be able to analyze a simple program and decompose it into programmable objects. In order to achieve that, we will be learning that there are problems that cannot be easily solved using simple procedural programs and how such problems can be solved using object-oriented programming. And we'll be looking at the concept of objects and classes. So in order to start, we will do a simple activity. We are going to simulate a simple game. Now read the small description shown next and identify the entities there. So pause here for a minute and identify the entities. An entity means a thing. So here I have identified the entities. We have Land of Mordor, we have Mount Doom, we have warriors, we have walking stick. There are many entities. Now, how are we going to simulate this game? Using a procedural program. A procedural program, as you might already know, breaks down a programming task into a collection of variables, data structures, and subroutines. It uses procedures or functions to operate on data structures. So here, to simulate this simple game, we have variables like name and category, and we have data structures such as the inventory, which has the hash map of inventory items of a warrior. And we can have further data structures such as the list of players and the categories likewise. Now, how can we specify what the players can do? Here the player name is just a string. And if you want to get the monster to steal the player's stick, how can we do that? So as you can see, it is not very straightforward to use procedural programs to solve this kind of problems. In contrast, in the object-oriented programming, as the name implies, we are using the concept of objects. That means our problem is broken down into a set of interacting objects. These objects have their own behavior and data. This behavior in the object-oriented paradigm we refer to as methods, and the data we refer to as members or attributes. More specifically, in object-oriented programming, we don't have separate procedures or data structures. What we have is an object that bundles these procedures and data structures together. Of course, these procedures and data structures should be related to the object. And these procedures will be executing on the data structures within the object, mostly, in most cases. So, as you can see, this concept of objects is very much related to the real world. So, in real world, we talk about things, so entities such as warriors, monsters, trees, and we have tables, chairs, pens, pencils, they are all things or entities. So, in object-oriented programming, these objects represent these entities around us. So, the concept is very much related to us. For example, if you think of an employee in a company, it's an entity, right? So we can get an object to represent this employee in an object-oriented program. So this employee will have its own data such as his name, ID number, salary and all, and then it will have different methods such as method to change his salary. So there can be multiple employee objects corresponding to different employees. So each employee handles the data only belonging to that particular employee. So if I am an employee, my employee object will handle only my details, not someone else's details. So that is something important you have to remember. So object is identified as having a state and set of behaviors. State means its characteristics, and behavior means what the object can do or what other objects can do to this object. So if you take another example, a bank account. If you take a bank account object, what will be its state? It has an account number and its current balance. However, keep in mind, state refers to the characteristics or the values of that object at a given point of time. For example, if you take the current balance of the bank account, today it will have one balance and tomorrow it will have another balance. So the state of the object is changing. So when we define the state, what we can get is the value of that object at that given time point. And the behaviors or the methods associated with this bank account can be the deposit methods and the withdrawals. So, when you deposit, what will happen to the account? What will happen to the state of this bank account? Specifically, it will affect the current balance. When you deposit, the current balance goes up. And similarly, when you withdraw, the current balance goes down. So from this example, now it is clear the behavior of the method can change the state of the object. So now we said that now when you talk about bank accounts, if you take a bank, there are more than one bank account. So now based on that simple employee example, now we know if there are many bank accounts, for each bank account, there should be a bank account object. So how are you going to go and create all these objects? For that, we are using the concept of a class. Class is a blueprint of the object. That means the class specifies what information this object will carry and what this object can do. And using a blueprint, just like you are using a cookie cutter to make different cookies, we can create multiple objects using the same class. So in order to further understand this difference between classes and objects, now think of a form that you have to fill. You went to a government institution and you were given a form. And what does this form have? It has a place to write your name, your age. So it specifies what information the form when filled should carry, but it does not specify the information. That means it just says name, but it does not give a particular name. It says age, but no particular age is given. So if you and your friend goes to the office and you get two forms, but the same form. So when you fill it, that is a new object that carries your information. And your friend has another form object that carries his information. But these both objects were initiated or created using the same blueprint form, which specified what information should be there. So now you should be clear about the concept of class and the object. So to further elaborate this, let's look at this bank account example. Now we have a bank account class. This class specifies what information is carried by the bank account object. So when John comes to the bank to create a bank account, a new object is created, and this object will have John's name as John and the balance as $5,257. And similarly, when Bill comes from this bank account class, we are creating a new object, the Bill's bank account object. It will have Bill's name and it will have this different balance. So whenever you create an object, that object is unique. It is different from all the other objects that are created from the same class. And remember, even if two objects have exact same state, that means exact same information, still they are two different objects. So to further elaborate on the attributes. So earlier we mentioned that an object has the state. The state is given by the set of attributes. So attributes are the characteristics of an object. So if you take a bank account, its state is given by the balance, the person name, and the bank account number. So these three are the attributes. And these attributes can be either simple or complex. So if you remember the previous lecture, we mentioned about simple variables and complex variables. The similar concept applied here. So a simple attribute is derived using a primitive type such as integer or boolean. In contrast, a complex attribute can be created using a data structure, such as an array or some other object, such as a string. And the methods, so we said an object has a set of behavior. In object-oriented programming, this behavior is described using the set of method. So a method is can be taken as a message that sends a request from one object to another, asking the second object to execute one of its methods. So assume this shows the employee class. As you can see, we have say attributes, and then we have method 1, method 2, method 3, method 4. Now assume one of these methods is the update salary method. So some other object, let's say the HR object, human resource object or something, it will call this update salary method. Then what will happen? The salary of the employee will be changed. So salary is an attribute. Now why the attributes are in the middle circle and the methods are in the outer circle? That is a very important principle in object-oriented programming, which we call encapsulation, and you'll be learning it in the coming lectures. So it means the attribute values, attributes of an object should not be exposed to the other objects. That means other objects should not be directly retrieve the attribute values. Rather, these values should be retrieved or modified by other objects via the methods. For example, if you look at the update salary method, what does it do? It goes and updates the attribute of the employee class. So this update salary can be called by other external objects, but they cannot directly access this salary attribute. So let's do a simple exercise. You can pause here and think of an object. And what does that, what is the class that this object belongs to? What are its attributes and what are its methods? So as an example, I'm going to take two color pencils. So I have a pink color pencil and I have a blue color pencil. So how many objects are there? We have two objects, the pink pencil object and the blue pencil object. So how many classes are there? Although there are two objects, there is only one class. What is that class? Pencil class. Now remember, I said when you have a class, you can use it to create any number of objects. Now here, using the pencil class, I have created two objects, the pink pencil object and the blue pencil object. So what are the attributes? So looking at these two pencils, we can see that they have different colors and they have different lengths. So the class would define the attribute as the color and the length. So our pink pencil has the attribute value color set to pink and the length set to the whatever the length it is. And similarly, when you create our blue pencil, its color attribute will be set to blue and its length will be set to whatever the length it has. So what are the methods, methods that these pencil objects can have? Very simple method, straightforward method is write method. So both the pink object will have a write method and our blue object will also have a write method. When this method is executed, the pink pencil will write in pink and the blue pencil will write in blue. So as you can see, although there are multiple objects, they all will be created using a single blueprint called the class. So I hope now it is very clear the distinction between objects and classes. So how are we going to identify the classes that we have to implement, or the objects that are there in a given problem description? A common practice is to look for nouns. So if you look at our initial game simulation, the monster, the warrior, the binoculars, they are all nouns. However, in certain cases, just using nouns can be misleading. So instead of nouns, what we should look for nouns in some kind of interaction. And in order to identify behavior of objects, we have to look for verbs. Now pause here for a minute and read this given small description and try to identify the objects in this small scenario. Now here I have highlighted not only the nouns but the interactions. For example, teacher is conducting a class. So if you take this phrase, what are the nouns we have? Teacher and class. So now would they qualify to be objects in this scenario? Yes. Why? Because teacher is in an interaction with the class. What is that interaction? Conduct. And if you look at the next one, he or she, that means the teacher, will show lecture slides on the projector. And now we have three nouns here. The teacher, lecture slide, and the projector. So, and they are in an interaction. What is the interaction? The teacher shows lecture slide on the projector. So, not that they are just only nouns, but they have some interaction among them. So this helps us to identify nouns that will qualify to be objects, and some nouns will just be attributes. For example, if we say the teacher has a name, right? The name is it should not be an object. It is just an attribute of the teacher class, right? So if you look, as I just explained, if you rather than just looking for nouns, if you look at the interaction between nouns, we can identify the set of objects that should be there in your program. And similarly, the verbs, conducting, that means a conduct, that is a verb. So we can take it as a behavior or a method, or show. So show can another method that the teacher is having. Likewise, we can identify the objects and then the behavior. And of course, the attributes can also be identified. So now we learned about classes. Now we said from a class we can create objects. Now in practice, in a Java program or a C# program, how are we actually going to create these objects? To create objects, we use a special member of a class called the constructor. So constructor is used to create the object from that class. So look at the word constructor. Constructor constructs objects. That means constructor creates or initializes objects. So when we are creating the objects, if you want, you can assign the values to the attributes of that object. So this simple code explains all these concepts that we have discussed up to now. Now remember, last week we discussed that all the code that we write in Java should be packed inside a class. Of course, there are other constructs such as structs that can stay outside class, but most of the code in Java or C# like object-oriented programs will be packed inside a class. So here we have a class called monster. A class is identified by the keyword class, and we use the curly brackets to show the scope of the class. So we have a group of statements that together make the class. So here we have the monster class, and we have defined the integer age and the string name. These are called attributes. And now we have the constructor. Remember, we just mentioned what a constructor is. So if you notice, the constructor has the exact same name as the class name. It is a must. So in this constructor, we are taking some parameters. So age and name. So in this constructor, we are setting the attribute values for the age and name. So as you can see now, when we create the object using the constructor, this piece, so two lines will be executed, and the created object will have its age and name already set. And we have two types of special methods, setters and getters. So setter, as the name implies, it sets the value of an attribute. For example, the set name method here will set the name of the monster. And similarly, getter gets the value. That means it returns the value of an attribute. For example, here the get name method, which has a return type string, will return the name of this object's name. So remember, what it returns is the name that has been sent for this particular object. So in addition to the constructors, getters and setters, you can have any other method you want. So as you can see, we have a steal method which takes the warrior as a parameter and call a method of that warrior. So this is a very good example to show that now within the monster object, now we can call the method of the warrior object. So, and when this method lose stick is called, the state of this particular warrior object will be changed. Why? It loses its stick. So the state of the warrior is changed. So now when we create an object, we have to always use a new keyword. So this is the way we should be creating objects. It says monster. Now we are creating objects of the monster class. We are saying monster1 equals new monster, and we pass the value. So when the monster1 object is created, it will already have the age as 15 and the name as mon1. Now if you want to create another one, we can say monster2 equals new monster, and we give its name and the age. Likewise, from the same class, you can create any number of monster objects. As you can see in this class, it only specifies that the monster has an age and name, and monster can steal the warrior's stick, right? But it specifies the age value or the name value. So this age and name values are set when the actual object is created using this by calling this constructor, and because we are passing these values. Of course, if you want, rather than taking these parameters in, you can hard code the values, or you can give default values. For example, we can say this dot age equals 10, or this dot name equals monster 2. So then when you create the objects, you will not be passing these parameter values. Every monster will have the same age and the name. But remember, these monster objects, although they have the same values for the attributes, they are different objects. To further elaborate the difference between attributes and variables. So when you say int age or string name, and down here we have new int, new age, they are all variables, right? However, the first set of variables, int age, string name, and the array my number, they are occurring outside any of the methods of the class. So they are at the method, the class level. So that means they can be accessed by any method in this monster class. In contrast, if you look at the int new age variable inside the steal method, it is available only within the scope of this steal method. And if you try to access it from the monster constructor, you will get an error because it is local to the steal method. So in the terminology, when this variable is local to a method, we simply call it a variable. However, if the variable is at the class level, that means it is common to all the methods and the constructor in the class, we call them attribute. So this int age, string name, we don't simply say variables, we say they are attributes of this class. And here we demonstrate the simple and complex attributes as well. So int age is a simple attribute because int is a primitive data type. In contrast, name is a complex attribute because it is of the type this string object. So in other words, the name refers to a string object. And next one is again a complex variable because this my num variable refers to a data structure, specifically an array. So next we have the tools attribute, which is an array list. So the difference between array and array list is when an array is created, its size is fixed. That means if we say the my num can carry only 4 values, throughout the program execution, it can carry maximum 4 values. However, in array list, the length or the capacity of this array list can be dynamically increase. So if you know the number of elements that you want to store, then you can use the array. But if you are not sure how many elements you are going to get to store, then use an array list. So that is some additional information. Finally, the difference between constructors and methods. So in the top part, I have given three different ways of defining constructors. The first one is the most comprehensive one, where we give the parameter values through the constructor. So these parameter values are used to initialize the attributes of the monster class here. In the next one, we are taking the parameter values, as you can see, but we are not using these parameter values to set the attribute values of the monster objects. Then if it is like this, then there's no point of taking the attributes, because we are not taking these parameters, because we are not using the parameter values inside the constructor. So in such a case, that means if you are not going to use any parameter values sent by an external object, you can simply have this kind of a blank the constructor with blank parameter list. So this we call the default constructor. In Java, if you don't specify a constructor, you can still create object using that class, because Java automatically inserts this default constructor. Although you can't see it in your code, inside the default constructor is added to the class when no constructor is defined. So next we have the methods. So these are different ways of defining methods. So the first line of each method we call the method signature. So as you can see, in the first method signature, we have public void steel, and within the parenthesis, we have the parameter warrior, that is of type the warrior class. So this first one is called the access modifier. We will learn the different types of access modifiers later. The next part is the return type. In this one, we are not returning anything from this method, so we just say void. The next part in the method signature is the method name. So here this method has the name steel, and the parameters. So here we take a parameter of type warrior. So the return type, access modifier, and the parameter are optional, for example. And when you don't have a return type, but you have to say it is void. In the second one, it looks the same, but rather than being a void return type, this method returns an integer value. So when the method signature says it returns an integer value from the method body, you must return an integer, otherwise you will get an error. And in the third example, you will see that it does not have the parameters. So that is why I said having parameters to a method is optional. So if you want, you can have a method that does not take any parameters. So especially the getters, they don't have parameters because they are just returning a value. But here, since still the return type is int, your method must return a value. And the next one, the most basic case, it does not return anything and it does not take any parameters. So depending on your requirement, you can have any type of these methods in your code. So in summary, today we looked at the basic of object-oriented programming principles, and we identified that in this paradigm, solutions to problems are given by in the context of set of interacting objects. So these objects have attributes and methods. To create the objects, we use classes as the blueprints. And when a class is used to create an object, the object is initiated or constructed by calling the constructor in the class. So in the next week, we will start looking at the other fundamental principles of object-oriented programming. Thank you.